Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, number 31 of NEET 2014 physics paper. Students, let us solve the next question, which is number 31. Two identical long conducting wires AOB and COD are placed at right angles to each other. Suppose this is my one wire, this is my another wire. They are not actually in contact, with one above the other such that O is their common. So this is AB, that is AOB wire, this is suppose CD, this is COD wire. And because the length of the wire is not given, so we'll assume that these are infinite long wires. This goes to infinity. The wires carry I1 I2 currents. Suppose that this wire is carrying current I1 and this wire is carrying I2 respectively. Point P is lying at a distance D from O, along a direction perpendicular to the plane containing the wire. So you cannot take a point on this paper, you have to take a point D just perpendicular to it, somewhere here, just above it. So how to draw this one? So you cannot draw that one, you have to imagine that this point is suppose here, but it is actually like this. Which point is P, whose coordinates are given. Obviously, if it is D, then XY coordinate will be 0 and Z coordinate will be D. So this point is actually in on the Z axis. P is on Z axis. So now the magnetic field at the point P will be. So what is the magnetic field at this point? Because the point is somewhere here. So at this point you have to find the magnetic field. So if these are the two cross wires X and Y and this is Z and the point is somewhere here, then because of this wire there will be a magnetic field, and because of this wire also there will be a magnetic field. And the net magnetic field we have to find. And to do that, we know that if I have a infinite long conductor carrying current I, then at a distance A D from this, if I consider a point here P, then the magnetic field at this point will be given by mu naught upon 4 pi 2. That means this is actually the current that is flowing I by D into sine of theta 1 plus sine of theta 2. Now if I take a specific length, not infinite length, then this is the end point of the wire and this is another end point. This angle is theta 1 and this angle is theta 2. So for a finite length of the wire carrying current I, we have this expression. But as the wire is infinite, this line will approach towards infinity. So for a very long wire, this angle will become parallel. So that means the angle will be 90. Similarly for theta 1, if this angle will go on increasing, and at infinite it will become 90 degree to this line. So any measurement is made with respect to this line only. So for the given case, theta 1 is equal to theta 2 equals to 90. If I substitute here, then we will have mu 0 upon 4 pi 90, it will be 2i upon d. This is the value. Now this is the expression for B for any infinite wire carrying current I at a distance D. Now, so in the given situation, we have two infinite wires. One is carrying current I2, another is carrying current I1. So if I consider a point just above it, then I will find magnetic field due to both the wires separately and add them in terms of vector. So if you think of this AOB, this one, the point is above it, the current is supposed that in this direction, then at this point the magnetic field will be given by mu naught upon 4 pi 2I, here is I1 to I1 divided by D. Similarly, and the direction of the magnetic field will be this side, in this direction. That means if I consider this as X, this as Y, and this as Z, then it will be in negative Y direction. So minus J cap direction. So magnetic field due to this I1 carrying current will be, suppose that it's B1, but its direction is along minus J cap. If I think of now I2 COD wire carrying current I2 in this direction, now this point is exactly here. Suppose that current is in this direction, or it might be in this direction, doesn't make any difference as far as the value of magnetic field is concerned, net magnetic field. Suppose it is in this direction, then again if I hold the conductor like this and current this in the direction of the current, this will give you the direction of magnetic field. So at this point the magnetic field will be in this direction, and this direction is positive X direction. So because of this conductor carrying current I2, the magnetic field will be B2, and it is in which direction? Positive I cap direction. Now we have got two magnetic field, one in positive I cap direction, another is negative Y direction, positive X and negative Y. So the net will be somewhere here, and the magnitude of both the B1 and B2 will be different depending on what is the value of I1 and I2, but it will be somewhere in this direction that we have to find, and the resultant is found by vector addition, square of this magnetic field plus square of this magnetic field, and then the square root. So first of all I will take B1, I'll find B1. From here I'll use this expression. If I cancel this, then this will be 2. So B1 will be in what direction? The B1 will be in minus Y cap direction, that is minus J cap. So this will be mu naught upon 2 pi. The current is I1. This is for AOB wire. I1 and divided by D is same for both the wires. And in which direction? Minus J cap. For COD wire, B2 will be mu naught upon 4 pi I2 upon D into I cap, that is positive. And these two vectors are perpendicular to each other, so in vector form. So the net value of B is asked. The magnetic field at the point P will be. This is the B net you have to find. In terms of the magnitude, the magnetic field at the point will be. This is given in terms of the magnitude. So this is the magnitude of magnetic field. You have to find the magnitude. So we have B net. Magnitude will be B1 square plus B2 square under root. Because if two vectors are 90 degree to each other, just you can use Pythagoras theorem, B1 square plus B2 square. Now B1 mu 0 upon 2 pi D is common, squaring this and going out. So squaring it and taking this at the outside, the square root, I just take initially starting from outside, there is no problem with that. Only the difference will be I1 square and I2 square. So this will be the situation, and this is your B net corresponding to the point P. So if I see the options, you can see here the option number 4, which is mu 0 upon 2 pi d, and I1 square, I2 square, and square root. This half power is there. Half power is square root of I1 square plus I2 square. Square root of I1 plus I2 square. So this is option number 4. So the correct answer to this question is option number 4. Okay. Thank you.